Okay, this lecture is on the idea of magnetic force, and essentially whenever there are two magnetic fields in the same region, a magnetic force is going to be exerted on the objects. In the same region, a magnetic force will be exerted. It's really wobbly. And this is either going to be an attraction or repulsion, depending on which way the magnetic fields are. Okay. So we're going to look at, well, how is it that you get these two different magnetic fields? And so the first case we're going to look at is the magnetic force on a charged particle. And to understand that, what you need to know is that when a charged particle is moving, it creates a tiny magnetic field around it. And if that moving particle is in an external magnetic field, then it will experience a magnetic force. So we'll say if it is in an external magnetic field, so this is where our secondary magnetic field is, the charged particle will experience a magnetic force. Let's be more specific. The moving charged particle experiences, I ran out of room, a magnetic force. And that's the key. The charged particle has to A, be moving, and then B, it has to be moving in an external magnetic field. If you just have a charged particle moving by itself and there's no external magnetic field, it won't experience a force. Or if you have an external magnetic field and you just have a charged particle sitting there stationary, it won't experience a magnetic force. Like, the two conditions must be met. You have to have a charged particle moving, and it has to be moving in an external magnetic field in order to experience the force. So let's go ahead and look at what the actual equation for magnetic force is. If you recall, our symbol for magnetic field was the letter B, and so our magnetic force is going to be FB. Okay, so that's going to be the symbol for our magnetic force. The equation is FB is equal to QVB sine of theta. And so here is where we have our two magnetic fields interacting. Or QV, a moving charge, so QV causes a magnetic field. And then this is a secondary magnetic field. And then this is the angle between them. And if you have those two magnetic fields in a certain region, we'll see a magnetic force occur. So let's just identify what these different quantities are. Q is obviously the charged particle. V is the velocity of the particle. B is the external, and that's key, it's the external magnetic field. And theta is the angle between the velocity and the magnetic field. Most of the cases, that angle is going to be 90 degrees because sine of 90 is equal to 1, and that maximizes our magnetic force. There'll be a few cases where the angle will be different, and it'll be pretty obvious what that angle is. And it's a force, so the units are going to be in newtons. All right? So we're going to just look at one example during this lecture of just calculating out magnetic force on a charged particle, a moving charged particle. So for this example, it says a particle with a charge of 0.03 coulombs experiences a magnetic force of 1.5 newtons if the charge is moving at 120 meters per second to the right at a 90-degree angle with a downward magnetic field, what is the magnetic field? So just in terms of a visual, you've got this particle, and it's a positively charged particle because it's just 0.03, and it's moving to the right. So there's the velocity. It's moving to the right at a 90-degree angle with a downward magnetic field. So essentially I've got this magnetic field that looks like that. Okay. So let's just go back to the problem and identify our quantities again. It's got a charge of 0.03, so that's the Q. It experiences a magnetic force of 1.5, so that's the FB. Charge is moving at 620 meters per second, that's my velocity, at a right angle, so that is theta. And then what is the magnetic field? So we're looking for B, or we're looking for that magnetic field. And so my equation for magnetic force is FB equals QVB sine of theta. And so here it's just a matter of plugging in the quantities that we know. So FB we identified as 1.5. Q is 0.03. V, my velocity is 620 times B, and then times sine of 90. And sine of 90 is just 1. So go ahead and take a moment and calculate that out. The video will pause for you to answer the question. And you should have gotten a magnetic field value of 0.081 Teslas, or Teslas are the units of magnetic field. All right? So when we get back to class, we will look at a few more examples of magnetic force and moving charge, and we'll also start to talk about the direction of magnetic force in relationship to the field and the velocity. That's a little bit more complicated.